Today we are going to be dealing with the definition of similar triangles. So, two triangles are similar if and only if the corresponding sides are in proportion and the corresponding angles are congruent. Now this is different than triangle congruency, because in triangle congruency the sides have to be exactly the same, but when they're similar the sides only have to be in proportion. For example, this triangle down here, ABC, would be congruent to triangle DEF, because this side is the same as this side is the same as this side, this one is the same as this one, and what I mean by the same is they have the same length, so AB would be the same length as DE. Also, we could prove two triangles are congruent using many methods. For example, we could prove these two triangles are congruent using side, angle, side. So AB and DE are congruent. Angle A is congruent to angle D, and AC is congruent to angle DF. So A, B, C is congruent to D, E, F. So that's something that we learned already in this year. But today we're going to deal with how to prove triangles are similar, not congruent. So there are three methods to prove that two triangles are similar. We could use side, angle, side, 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 or angle, angle. Today we're going to be doing side, angle, side. Alright, now the main thing is to be careful. Side, angle, side for similar triangles is not the same theorem as we used for congruent triangles. To show triangles are similar, it is sufficient to show that the two sets of the corresponding sides, so AB and DE, and AC and DF, are in proportion, and the angle included between those two sides are congruent. So the theorem states, if an angle of one triangle is congruent to an angle of the corresponding angle of another triangle, so angle A is congruent to angle D, and the lengths of the sides including these angles are in proportion, the triangles are similar. So we have the angle A is congruent to angle D. Then in order to prove that these two are similar, we need to figure out if AB over DE equals AC over DF. Now in order to do this, we're going to practice a few different examples so that we can get the hang of it. So, for example, we have two different triangles right here. We have this angle is 52 degrees and this angle is 52 degrees. This side length is 10 and this side length is 2. This side length is 15 and this side length is 3. So we need to figure out if 10 over 2 equals 15 over 3. Now notice, the numerator is from this triangle, so 10, and the numerator over here is also from this triangle, and the denominator is from this triangle, and the denominator is from this triangle. They always have to match up. We could also rewrite it as 10 over 15 equals 2 over 3. These two things end up being the same thing, but again, they have to match. So the numerator and denominator match this triangle, and the numerator and denominator match this triangle. Alright, now let's test to make sure that these two, that 10 over 15 equals 2 over 3. One way we could do this is by cross multiplying. Alright, so 10 times 3, we get 30. And 15 times 2 is 30. Thus, we know that by setting up this proportion, that 30 equals 30 is true, so these two side lengths and these triangles are in proportion. Let's just check to make sure that this equals the same thing. So cross multiply again. We get 30 equals 10 times 3. We get 30. Alright, so that just shows you that either way that you set up the proportion, it's still going to equal the same thing. So we know that these two sides in these triangles are in proportion and the included angle is congruent. So we can state that these two triangles are similar by side, angle, side. Note the difference between similar and congruent. Congruent means that these two sides would have to be the same. But similar means that they're in proportion. So the proportion of 10 over 15 is the same as 2 over 3. And the included angle is congruent, so they're similar by side angle. So we are given two different triangles, triangle ABC and triangle DEC. We can set up a T-chart, so a statements and a reasons chart. The first statement is going to be AB equals 6, BC equals 3, DE equals 4, and EC equals 2. Now the reason for that is because it was given to us. Okay, so now let's look at these two triangles. So we had AD equals 6, DC equals 3, BE equals 4, and EC equals 2. What we're going to want to do now is find the length of AC. So we can state that AC equals CD plus DA, and CD equals CE plus EB. So AC equals the segment CD plus the segment DA, and CB equals the segment CE plus EB. The reason for that is the addition postulate. Alright, now that we have those lengths, AC and CB, we can set up a proportion. So we have CA over CD equals CA would be 6 plus 3, which is 9. We have 9 over 3. We can reduce that to equal 3. And also we have CB over CE equals CB would be 4 plus 2, which is 6, over CE, which is 2. Again, we can simplify that to equal 3. The reason for that is just substitution. We just substituted what we had into our proportion. Alright, next we can state that CA, so CA over CD, right here, is the same as CB over CE. So CA, so this side length, over CD is the same as CB over CE. And the reason for that is the transitive property. Alright, next. Now that we have the sides are in proportion, so this side and this side and this side and this side were in proportion, we need to state that the included angle is congruent. So we can state that angle C equals angle C. And we know that because that's the reflexive property. Alright, finally, we can state that triangle CDE is similar to triangle CAB. And the reason for that is side, the included angle, and the other side. So side, angle, side, because we know that the sides are in proportion, and the included angle is congruent. Thus, we have proven that triangle CBE, this littler triangle, is similar to triangle CAB. This concludes our lesson. Tomorrow we will be doing how to prove triangles similar using side-side-side theorem.